Welcome to iCode. Today we will see how to delete a node from a doubly linked list. The previous video we discussed how to create a doubly linked list and how to insert a new node to the doubly linked list. Okay. Today we will see how to delete a node from the doubly linked list. In same as the singly linked list, here also we have three cases. That is delete the first node, or delete the last node, or delete a specific node, right? So far we have a doubly linked list, and we created the list to store some integer values. Okay, running the program. Okay, you can see here we have 6 nodes, and values are 10, 20, 30, 40, 50 and 60, right? The first output indicates the forward traverse, and the second output indicates the backward traverse, right? That is the use of doubly linked list. Okay, first we will see how to delete the head node of a doubly linked list, right? Okay, you can see here this is the appearance of the doubly linked list, and there are two references to access the list: head reference and tail reference. Head reference is pointing to the head node, that is this 100 node. This 100 indicates the memory address of the node, and the tail reference is pointing to the last node. Okay, in order to delete the first node, we need another temporary reference. Here you can see I have created or constructed a function called delete first node. Okay, now let's try to how to implement the function. First of all, we can check whether the list is empty or not, right? Or we have to do nothing, right? If right, head reference is not pointing to any node, it means the list is empty. We can simply give the message as the list is empty, right? Okay, else mean now suppose the list has some nodes, and we are going to delete the first node, right? As I said, we have a temporary reference type node because we hope to use this temp reference to access a node of the list. Therefore, the type should be node, right? Now we have a temp reference, and it is pointing to the head node. Okay, now what we have to do is we have to move this head reference to the next node, right? Next node is 200. You can see here we stored the memory address of the next node, right? That is 200. Okay, because after deleting this 100 node, then the head node is this 200 node. Okay, so first we have to change or move head reference to the next node, right? In order to do that, we have to store here the memory address of the next node, that is 200. Then this link doesn't exist anymore, and we have a new link like this. Okay, else first we can move the head reference to the next node. You can use here the temp reference as well, because you can see here the temp reference is also pointing to the head node, right? Okay, then what we have to do is we have to break these two links, right? Because after deleting this 100 node, we do not need these two links, right? In order to do that, first I will break this previous link of the 200 node, right? Okay, now this link doesn't exist, and then I can break this link by using this temp reference. Okay, in this way you can delete the first node of an existing doubly linked list. Now this link doesn't exist anymore, and you can see here now this 100 node has gone, and this is the new appearance of the linked list. Now the head node of this 200 node, and so on. Okay, in this way you can delete the first node of an existing list. Okay, now let's see how to delete a last node, how to delete the last node of the list, right? You can see I have created a function called delete last node. Now we are going to delete this 500 node, that is the last node of the list. In the same as the previous case, here also we need some temporary reference and point it to the tail node, right? Okay, here you can see now we have a temporary reference called temp, and it is pointing to the tail node, right? Okay, we will do it first. Create a temporary reference and point it to the tail node. Then easily we can break these two links, and we have to move this tail reference to the previous node, that is 400 node, because after deleting this 500 node, then the tail node of the list is 400 node, right? First we remove this link and make a new link like this. In order to do that, we can change this memory address to 400. Okay, first we will move the temp reference to the previous node. Now we can remove these two links by using this tail reference and temp reference. First I will remove this next link of the 400 node, right? Okay, what we have to do is we have to next point of the tail node is equal to none. Okay, then we can, okay, now this link doesn't exist, and now we can remove this link by using this temp reference. In this way you can delete the last node of the list. Okay, now you can see the last node of the list is 400, and Java has a garbage collector, and this node doesn't exist anymore, right? It is removed from the memory. Okay, now let's see how to delete a specific node from an doubly linked list. Okay, here you can see I have constructed a function called delete specific node, and I passed some parameter, integer parameter called position, because if you need to delete some specific node, then you can then you should give the position, right? That's why I take integer variable called position. Okay, here also we need some temporary reference and set it to the head node. A temporary and I take another variable type in, and it is initialized as 2, right? Then we need some while condition. Okay, the condition is I less than or equal to position, right? Okay, inside the loop we can simply move the temp reference to the next node. Okay, at the beginning we have a temporary reference, and it is pointing to the head node, right? And we have another variable, and it is integer variable, and it is equal to 2, right? Now comes to this line, and okay, now check the condition, right? Now I is equal to 2 and position. Okay, now suppose we are going to delete the third node, right? That is the position is 3, right? Third position node is 300 node. Okay, now the position is 3, then the condition 2 less than or equal to 3, right? It is true, then comes into the loop, and temp equal to temp dot next, mean temp dot next is equal to 200. It means temp reference is moving to the next node, right? Like this. And also here we have to increment I by 1. Okay, now now I is equal to 3, and then check the condition. Now 3 less than or equal to 3 is correct, and again comes to the loop, comes inside the loop, and temp moving to the next node, means Now this is changed 300 node. Okay, now again I increment by 1, then that is I is equal to 4 now. Now check the condition, 4 less than or equal to 3. Now it is false and end the loop, right? Okay. Now the temp reference is pointing to the goal node or goal position. Now we can remove this 300 node or the third node by using this temp reference, right? After deleting this 300 node, the next node of the 200 node is 400, right? It means there would be a link like this, right? In order to do that, we have to store here the memory address 400, right? Then this link doesn't exist. Okay, let's see how to do it. After completing the while loop, this way you can create the first link, right? That is temp.previous.next. It means now temp is pointing to 300 node. Temp.previous means here you can see 200. That is this 200 node, and here you can see previous dot next. It means next point of the previous node, that is 200, is this, right? We stored here 400. It means we have a new link like this, right? Okay, then what we have to do is we have to set the previous node of this 400 node as 200, right? In order to do that, we can change this to 200, right? Okay, it means now we have a new link like this, right? Same as previous, we can create that link in this way. Okay, now this link doesn't exist, and now we can remove next link and previous link of 300 node by using this temp reference, right? Okay, now these two links, this doesn't exist, and Java, as I mentioned previously, Java has a garbage collector, and this node doesn't exist anymore, and it is removed from the memory. Okay, in this way you can delete a specific node or a specific position, a node existing in the specific position. Okay, now let's see the output of the program. Okay, running the program. Okay, you can see here before delete the first node, right? The first value of the list is 10. After, you can see here deleting first node. After delete the first node, now first value of the node is 20. That is, it means it works correctly. Okay, now let's see how to delete if last node. Here you can see I have called delete last node function, and running the program. Okay, before delete if last node, you can see here the last value of the node of the list is 60. After deleting the last node, now the last node is 50, right? Now it's worked correctly. Take a look here. I have called delete specific node function, and I will give the position as 3 because suppose I need to delete the third element, right? The third element of the list is 30, and let's see the output. Okay, here you can see after deleting the third node, now third value of the list is 40, right? Okay, you can try another position. I will give 4, right? Check the output. Here you can see the fourth version of the original list is 40. Now the fourth value of the list is 50, right? Okay, in this way you can delete a specific node of a doubly linked list. Okay, if you got some knowledge from these videos, don't forget to subscribe, and the next video, let's see how to create a circular linked list. Okay, if you have any doubts, please put it in the comment section, and thanks for watching. Thank you.